Welcome. In the next few minutes we will break down VLANs, what they are, how you configure them, and how traffic actually flows through them. No jargon overload, just the core logic. Let's start with the problem VLANs were invented to solve. Imagine a single switch with every device plugged into it. By default they all live on one network, one big broadcast domain. Think of it as one large room with no walls. When any device sends a broadcast, every other device hears it. That creates two headaches. First, congestion. As you add devices, broadcast traffic grows and everyone is interrupted by messages meant for someone else. Second, security. There is no separation, so the finance computer and the guest laptop sit on the exact same network. We need a way to divide this one switch into separate networks, without buying more hardware. That is exactly what a VLAN does. VLAN stands for Virtual Local Area Network. It lets you take one physical switch and split it into several logical networks, using software instead of extra cables or boxes. Here we have created two VLANs, VLAN 10, in teal, for engineering, and VLAN 20, in amber, for sales. Now the switch treats them as if they were two completely separate switches. A broadcast from an engineering device only reaches other engineering devices. Sales never even sees it. We have built walls inside the switch, and those walls are just configuration. But here is a question. If one cable between two switches has to carry traffic for several VLANs, how does the other side know which VLAN each frame belongs to? The answer is tagging. The standard is called 8.2.1q. When a frame needs to cross between switches, the switch inserts a small tag carrying the VLAN ID, for example VLAN 10. This gives us two kinds of ports. An access port connects to a single device, like a PC, and carries just one VLAN, untagged. A trunk port connects switches together and carries many VLANs at once, using these tags to keep them apart. Access ports for devices, trunk ports between switches. Let's see the actual configuration on a Cisco switch. First we create the VLANs and give them names. Then we take a port, interface fast Ethernet 0/1, set it as an access port, and assign it to VLAN 10. That port now belongs entirely to engineering. Next, the link to the other switch. We pick interface gigabit Ethernet 0/1, set it to trunk mode, and allow VLANs 10 and 20 across it. Finally, show VLAN brief lets us verify which ports ended up in which VLAN. That is the whole core workflow: create, assign, trunk, verify. Now let's follow the traffic. First, two devices in the same VLAN. PC and PCB are both in VLAN 10. When A sends a frame to B, the switch sees they are in the same VLAN, looks up the address in its table, and forwards the frame straight to it. This all happens at layer 2. The switch is simply switching. It is fast, direct, and no router is involved. Same-VLAN means the switch handles everything on its own. But what happens when devices are in different VLANs? PC is in VLAN 10, and now it wants to reach PCC in VLAN 20. Remember, each VLAN is its own separate network, its own subnet. And a switch alone cannot move traffic between different networks. For that you need layer 3, a router, or a switch that can route. In this classic setup, called router on a stick, the frame travels up the trunk to the router. The router has a subinterface for each VLAN, one for 10, one for 20, each with its own gateway address. It receives the frame on the VLAN 10 subinterface, routes it, and sends it back down tagged for VLAN 20, where it finally reaches PCC. Different VLANs always need a router or layer 3 switch to talk. So, why go through all this? 4 reasons. Segmentation. You group devices by role, not by where they happen to be plugged in. Security. Sensitive systems stay isolated from the rest. Performance. Broadcasts stay inside each VLAN instead of flooding everyone. And flexibility. You can move a user to a new VLAN with a config change, not a new cable. That is V-LANs. One physical network, many logical ones, with routing to connect them when you choose. Thanks for watching.